Hello friends, this is Sandeep Deshmukh. Welcome to the webinar. Sorry for the small goof up, there were some issues and hence we had to create this new link. Thanks for joining on this one. We will start the session soon. So Priyanka will be taking over the session. Before that, I just want to tell you the way we will interact for any questions and answers. If you have any question, please feel free to raise your hand. There's a button to do that. As an organizer, whenever I see that, at the next logical break, we will stop and I will unmute that person and that person can ask the question. And then Priyanka or anyone else can answer that. Okay? Handing over the session to Priyanka. Thanks.
Good evening, everyone. This is Priyanka Google. I am working with Data Torrent for almost 2 years now. I'm a part, and also I'm a part of Apache committers, Apache Apex committers web so, as a part of a webinar series by Apache Apex, today we are conducting this session to introduce Yarn or to look into details of Yarn. So, what do we expect from this session? So to start with, we'll first look into the Yarn architecture. We'll try to understand what is Yarn, and once we have some clarity about Yarn, we will go ahead and see how to build a Yarn application. Okay, so I'll start with the first thing, why Yarn. So before understanding what Yarn, let's see why Yarn. Like why Yarn was created. Once we know that, it is easy for us to understand why the Yarn is in the way it is. So to answer this question, why Yarn, I'll take a step back and go into Hadoop 1 architecture. Hadoop 1 is even very famously known as a MapReduce architecture. In this Hadoop version 1, if you want to write an application, you have to write your application in MapReduce phase. That is, in first phase, your input will be divided into small chunks and the map tasks will run on that to compute some results based on your logic. And in reduce phase, the output of this map tasks will be consolidated to give you the final output. Which means if you want to write an application on top of Hadoop, you have to write your application in this MapReduce fashion. And to run these MapReduce jobs, Hadoop has provided you some architecture, which looks something like what is shown in this diagram. This backend architecture had two major components. The first one is job tracker, which takes care of all resources in your system. Also, it takes care of scheduling all the jobs in your cluster. And the next component is task tracker. The task tracker sits on each and every node of your machine, and it takes care of executing the tasks which are submitted to this machine by job tracker. So this is a lightweight process and it sits on each and every node, whereas there is only one job tracker in your cluster. So having looked at this architecture, I'll see, like, I'll try to explain what all limitations were there with this architecture. That's why people tried to improve it and came up with Yarn. So what were the limitations? The first thing I see is scalability problems. Why? Because we have only one job tracker and the entire cluster limitation is proportional to what a job tracker can handle at a time. So as per the lab test, it is proven that a job tracker can handle maximum 4,000 nodes and maximum of 40,000 concurrent tasks at a time, which could be a limitation in this current era when the big data is growing bigger every day. You are getting more and more data and you want to scale more to process that data. So this can be a limitation in your system. The next one is about availability. So what if your job tracker goes down? We have only one job tracker. So if it goes down, your entire cluster comes to a halt. No jobs can run without job tracker. And this we don't have any redundancy, so it is like one of the big one of next limitations, which is availability. And if you want to run 24/7 in production, this is a big limitation. Next is resource utilization. So as we have seen, Hadoop version 1 is about mostly about MapReduce processing. So when you submit your application to this Hadoop version, Hadoop to run your application, it allocates some resources to you to start with. And these resources are tagged as either MapReduce resource or a reduced resource. So whenever the map slots are working, the reduced resources are waiting for the inputs, because the output of map phase goes to the reduced phase. That means all the compute resources cannot be used all the times, which leads to underutilization of available resources. And the last and the most important thing is you have to write your application in MapReduce format, which can be a limitation because it's not always possible to write your applications in a certain fashion, because you want to achieve different things and it is not feasible. Yeah, so this looks like there are some limitations and we want to do better. That's why people came up with new ideas and they built the YARN. So YARN stands for yet another resource negotiator, and YARN allows you to, it allows you to run any application in your distributed fashion. I mean, it doesn't have to be MapReduce, it can be any program, and you can decide to run in distributed fashion with using YARN. And taking this help, taking the help of YARN, a lot many frameworks has been evolved. Some of the examples I can tell, like Apache Spark, Apache Giraffe, and the most important Apache Apex are the framework or the applications which are developed on top of YARN. So if anyone has any questions, I'll take a small break. Please ask them.
Yeah, Pankaj, go ahead and ask your question.
Sure. Hi. Can you put some light on MapReduce 2? How is different from MapReduce 1?
Yeah, so MapReduce 2 is basically the YARN architecture, and the next slides will explain that.
Sure. Thanks.
I'll go into that. Yeah. Is there any other question? Okay. So I'll go ahead. So to answer Pankaj's questions, so next slide, from next slide we'll see that. So in this slide I have just highlighted some of the different type of programming which you can do on top of YARN. So along with MapReduce, you can do a lot more now. You can write interactive programs, you can write streaming applications, you can write the graph libraries, you can do a lot more than just MapReduce or the batch processing. And that's why it is told that YARN has taken Hadoop beyond batch processing. And now let's see how YARN is different than MapReduce 1. I highlighted some major components which are different in version 1 and version 2, that is MapReduce architecture and YARN architecture. So as we have seen, job tracker has been a bottleneck for us till now in Hadoop version 1. So the responsibility of job tracker is divided into multiple components. The first one is resource manager, then there is application master and timeline server. We will see details of these components in coming slides, but I'll just tell quickly that timeline server is the one which will track the history of all the applications running in your cluster. Then the job tracker from version 1 is equivalent to something called load manager in version 2. And the processing slots, which are like max slots or reduced slots of version 1, are equivalent to the containers of version 2. The container is a placeholder. Whenever you allocate the resources in YARN, they are allocated in the form of container, where you can ask for the memory, the processing power right now, and going ahead, maybe the support will come to ask for network speed, the disk utilization and all, but that is not yet provided by Hadoop. So now let's look into YARN architecture. I think that will be very interesting. That's what we want to know by looking at all these advantages and all. So how is YARN? So I'll just explain the components. we just saw. The first thing is resource manager. Now the resource manager will take responsibility of managing all the resources in your cluster, as well as it takes care of scheduling the application. Then the next thing is node manager. It sits on each and every node, and it is responsible for managing lifecycle of container. Now container is a processing unit which is launched on that node, and the node manager is responsible for launching a container, tracking the execution of that container, and then killing the container whenever it has been asked to do so. And the next and the most important thing is application master. So in this yarn world, each application has an application master, which takes all responsibility of executing that application. This responsibility has been split from the job tracker of previous version, and it is per application now. So we'll see more details of this, but we just have to remember that now there is a per application master which will take care of executing the application thoroughly. And all these resources communicate with each other to take care of execution of an application. So I'll highlight some communications like all the node managers keep sending heartbeats to the resource manager, and with this heartbeat they send the status on that node, like what all containers are launched, like what is the status of each container. If some containers are dead, so it will inform everything to the resource manager. This is how a resource manager can keep track of all the available resources in the cluster. And again, there are some, I won't go into all details, but there are some different kind of communication happens, like when a job is submitted, or when the when application master want to ask for this, it will talk to the resource manager and all. I think we have some questions. I'll pause for a minute.
Pankaj? Hello? Pankaj? You're on mute, Pankaj. Can you go ahead and ask the question?
Yeah, so Priyanka, I'm still not able to understand like the difference between application master, because it also does the scheduling which resource manager do. So is it like a resource manager client on your node, the application master?
I'll tell you quickly, like in version 1 you have seen that it takes care of scheduling all your jobs, and here you see that resource manager still does scheduling of applications. That's why it could be confusing. But in version 1, the scheduling of jobs means it has to track each and every task related to a job. So a job is a bigger application which you want to run, and that will be divided into small tasks of map task or reduce task. So the job tracker has to manage everything, like each map task, each reduce task. But here in version 2, resource manager just initiates the first process of that application, which means application scheduling. But it doesn't care about what all task that job creates. I'll explain that more in detail, but once application master is launched, it will take care of launching more processing slots or the containers and get the job done for that application. After that first process is launched by resource manager, it is not concerned with what happens with that application. Does that answer your question, or?
Yeah, it does. So is application master optional, because I don't see that on the third node?
No, it is not.
Okay,
I'll tell you why it is not on third node, because every application has only one application master. So here in this diagram I have two applications. One is highlighted in pink color and another is in blue color. So each application has only one app master, and it could run on any node. So as I have two applications, you see two app master, and each app master can have any number of containers. It depends on the need.
Got it. Thank you.
Okay. Any other questions? No. Okay. So I'll go ahead. Now, as we have understood some basics about architecture of yarn architecture, let's see what happens behind the scene when we submit an application. Like when we say Hadoop to run your application on top of yarn, what all things happen in the backend. So to explain that, I'll assume I have a 3-node cluster. The one of my node is resource manager. This resource manager has two major components. One is scheduler and another is applications master. Applications manager, sorry. And I have two more nodes which has node manager installed on them. So we have only one resource manager, and we can have a lot many node managers. As of now, in this diagram, we have only two. Okay, so this cluster is up and running. It has Hadoop version 2, that is Yarn, running on all of them. Now, as an application developer, I want to submit an application on this cluster to run my jobs. So what I need, the first thing I need is a process which will talk to this cluster to submit our application. Sorry, I'll just go back. Okay. Okay. So this is called as Yarn client. So you need to launch this Yarn client process. The first thing you have to do. After that, Yarn client will talk to the resource manager to launch your application. It will ask resource manager to launch the particular application, and while doing that, it will provide with some basic information like what are the memory requirements for the application master, which is the first process launched for any application. That means whenever you run an application on top of Yarn, the first process is launched is application master, and the Yarn client tells the resource manager that I need X amount of memory and CPU processing speed capacity for this application master launch. It will also tell it like what all commands or what kind of program it needs to run application master. Having said that, application master is a custom code. I mean, you can code anything inside application master. You can decide to run any kind of code which will take care of your application execution. So Yarn client has initiated from its side. It has told resource manager to launch its application. Now applications manager from resource manager will take the responsibility and find a node which can host the application master with provided specifications. So let's say it has found a slot on one of the nodes, where now it will ask that node to launch the application master. Application master also runs inside a container. So now the first process of your application is running, which is application master. Now this process will register itself with the resource manager to tell it that it is running on this particular machine. This is important because any of the outside clients like Yarn client can inquire resource manager at any point of time to ask it the status of application. And if it knows the address of application master from resource manager, it can directly talk to it. The next thing it does is it asks for resources to resource manager. The application master, being the first and responsible process in our application, it will do all the needful work to run your application. So when the application master will know to run your application, what all processing power it will need, like what all resources it will need. Accordingly, it will ask resource manager that please provide me X number of containers with these specifications. When resource manager gets this request, the scheduler from resource manager will find the required number of container slots in your cluster and will get that with this information to the application master. Now application master, when it has all this information, it will contact the respective node manager and ask them to launch the containers to run the application. So having said that, all the containers will be launched and your application goes into running state. At this stage now, my application is running and it is doing whatever computation it is supposed to do. The computation could be actually anything. It could be running simple commands, or it could be little complex like reading files from Hadoop or for some third-party source, or it could be about processing something like running some complex rules or anything. So there is no restriction at all. You can run anything inside this container. And once this is in launch, once this application is launched and running, after a while, when all the applications are done, that information will be communicated to application master, and application master will unregister itself from the resource manager and declare its life cycle is completed and die. This is how a life cycle of an application happens. I'll take one more pause to see if anyone has any questions.
Daniel, yeah, please go ahead with your question.
Hello. Yes, I had a question. I don't know if that's going to be covered, which is when there's, in your example, what happens when there's a container contention for physical resources? Is there a way to enforce application quality of service or a hierarchy in terms of prioritization for certain applications through application master, or is that done through another module in Hadoop?
So as I understand your question correctly, you want to say if there are no enough containers available, what happens? Like, is there any prioritization for applications?
Yeah.
So as I'll first tell what happens when resources are not available. So let's say application master connects to resource manager and asks for containers, and unfortunately that processing power is not available right now with resource manager. So it will get back to the application master telling that the request cannot be served at this time. I mean, there are no available containers, and maybe application master can try some other time. So application master is a custom written code. You can write the logic like after some time keep retrying, keep asking for the container, and assume you will get it some amount of time. And about priority, I'm not sure if you can. I mean, you as an application master, you can prioritize your own containers, but resource manager doesn't do any of such prioritization amongst different applications.
Okay, does that answer, Daniel?
Yes, that answers my question. Thank you.
Okay, thank you. Pankaj, go ahead.
Sure. So, Priyanka, the flow that you explained, is that true for real-time jobs as well as batch jobs?
Yes, actually, the bad job is nothing but a map task running in a container or a release task running in a container. So it is actually true for any kind of task, any type of job.
But then, how does the scheduler take into account that whether it's a batch job or run job, which node, like for the batch job, which node has that data, and for real time, which stream has that data? Like, how does that coordinate? Like,
So, Pankaj, this is Sandeep here. Well, I may not have the right answer, but I can guess here. Basically, in case of MR2 compared to MR1, MR2 is the difference is we have the application master for MapReduce jobs already written by Hadoop developers, right? So, given that there could be some provision, or basically you can ask Jan about some, I would say, hints for your containers, and that can take care of your data locality. As well as the scheduler that is used also will matter, whether you are using capacity scheduler or default scheduler or something like that, which takes care of data locality or not.
I
Right?
see.
Yeah.
Right. And like, how does the failure mode works in this architecture in case resource manager fails or the node manager fails during the job execution? If you can put
Yeah,
light on that, that would be.
yeah, that's an important point actually. So what happens like in this Hadoop version 2, it has a provision to configure the standby resource managers. So if a resource manager fails, the standby copy should kick in and take the charge and start working as a new resource manager. Whereas if a node manager fails, we have already seen in previous diagram that each node is supposed to send heartbeat to the resource manager. So if a resource manager detects like one of the node manager is not sending heartbeat for some default configure time, I think by default it's 10 minutes. So if it detects it haven't received any heartbeat in 10 minutes from a particular node, it assumes it as a dead and reschedules all the containers which were running on that machine on some other machines.
including the application master container, right?
Yes, right.
Okay, got it. Thanks.
Okay.
Jeevan? Yeah, go ahead and ask your question. Jeevan, you there? I have unmuted you. Go ahead and ask your question. Dilip? Dilip Kumar?
Can you hear me?
Yeah, go
Yes,
ahead.
can you hear me? Yeah.
Yes.
So my question is, what are the best resources to get started with Hadoop Yarn architecture? What platform do you need to get started? And what kind of application you can develop using Hadoop Yarn architecture?
Okay. Okay, I'll give links to some resources at the end of session, but I can quickly mention that Hortonworks sites and Hadoop sites itself has really good material to look into. And to answer your second question, like what kind of applications, and there is absolutely no restrictions actually what you can run as part of a container on this when you launch your application. Only thing is you have to figure out like as an application what makes sense to be run on a distributed environment. So you can for to give you an example, let's say you have a very big file and you want to read it, and you want to use parallel processing, like you want 4 of your machine to read it parallelly to increase the speed of read. So you can launch the containers, ask each container to read the part of the file, and you can do it faster. So absolutely, like technically there is no restriction what you can run as a YARN container, but I think you have to make some decision based on like your design, like what makes sense to be run as a distributed application.
Okay, can you send me some examples also later, like
yeah, sure,
what
we can do
applications
that.
you have? Okay, yeah, thank you.
Definitely, we can do that.
Yeah, sure, thanks.
Yeah, thanks, Dilip. So there is one more question by Jeevan. He has typed it. How does it handle long-running jobs?
Actually, your jobs can be running really long, like few days or months. Like Apache Apex is one of the YARN application. How it is a YARN application, we will see it in next sessions. But I mean, Apache Apex is a YARN application, and it actually runs for months together. I mean, it doesn't like as it is an online streaming application, it runs without any break for months. In case of any node failures or container failures, the Hadoop helps us to reschedule those containers, or if that node is dying, it helps us to replace the nodes. So we can actually, there is no restriction actually on the amount of time.
There is one more question. Can we reuse the containers?
The containers as such are not reused. When a container process life cycle is ended, it is killed, and same processing slot is used to launch next container. I mean, you can, if you look it as a physical entity, you can reuse it, but as a logical thing, it is destroyed and new container is launched in the same place.
Yeah, and there are some more questions on setup and all. At the end of the session, we'll answer them, like how do we set up YARN and all. I think we can take them up at the end of the session.
Okay.
Okay. Yeah.
Can I go ahead?
There is one more question.
Hey,
Yeah,
sorry,
go ahead.
Priyanka. Yeah, sorry for asking too many questions, but
No, it's good actually.
So when you submit the application,
Mm-hmm.
does it create application master container on any randomly on any node, or because see it, so, or is it the case that the application master works with RM twice with respect to the specification?
No, I think the first guess was right. Like it is spawned on any node based on availability. Like if a node is having enough resources to host it, it will host it. I mean, there is no restriction as such.
Right. And
Application master is like any other container. I mean Hadoop infrastructure, there is no distinction.
can I picture this container as like a Docker container? Like you can, it contains your application. Like if you can
No,
define that.
actually, you can imagine it as a process. If
I see. Right. I'm not sure if we are going to cover this, but is there a difference between HDFS with version 1 and HDFS with version 2? Like,
uh, I'm not going to cover that, and I'm actually not aware right now. I mean, I'll have to
oh,
go
that's
back
fine.
and check.
That's fine. Thanks.
Does anyone? Can we go ahead, or we have more questions?
Yeah, go ahead. Some of the questions are there. I'll announce them at the end because they make sense at the end.
Okay. So I think having understood this, as a developer, we are very keen to try our hands and try to write an application. So let's say you have like plain vanilla yarn with you and you want to write an application. Let's in the next session, in the next slides, I'll go through some pseudocode, like what all things you need to do to write an application on top of yarn. I'll quickly like to mention one thing, like the next slides which we are going to understand. Normally in your production systems, you won't go to this depth and write all this code. Hadoop community has really matured, and there are so many open source frameworks which will do all this basic coding for you, and you just need to write your application on top of that. But I would like to cover this just to build. First thing is we want to build the understanding around it, and second thing is once you understand this, you will understand the Apache Apex as a yarn application very clearly. So let's start with this. We'll see how code will look like if you do everything which we have seen as a diagram. Like if you want to write in a code, what you need to do. So I have highlighted some of the major steps you need to take, and I'll mention one more thing. Like all these classes and functions I have used over here, they are exposed by Hadoop library. So while coding, you need to use Hadoop libraries to use this function calls. The very first thing you are expected to do is you need to start a yarn client service. So you can use yarn client class from the Hadoop library, and you can start that process using .start function call. It will just launch that process. In that once your yarn client is launched, you need to create the application object. Like there is a function called create application. You call it, and you will get a application object. This application object you will submit to the resource manager, so that resource manager can launch your application. So along with this application object, you need to provide the resource manager some basic information. Like what will this information will be? This information goes as part of application submission context, and this context contains information like what is your application name, what is the application priority. I think there was some question with respect to priority, and as I said, like there is no container level priority distinction, but you can set it at application level. Then there you need to set container launch context. I'll go into details of container launch context in next slide, but here I'll quickly mention it is the information required by the node to launch a particular container. Once you set all this information in your application submission context, you submit this information to resource manager, and you tell it to launch your application. So you use this submit application function call and ask resource manager to launch your application. Now, as we have seen, resource manager, applications manager from resource manager will kick in. It will find a particular node to launch your application, and will start your application master. Now, application master is again custom code. Like you can write anything in your application master. Application master is a thing which will decide what your application looks like, what all things you need to do to run your application. Before launching your application, it does some basic steps, and these also you need to code if you're going to write your own application master. First thing you need to do is register yourself as application master with resource manager. You use this register application master function call to do that, and you use AMRM client protocol to talk to the resource manager. After registration, you ask resource manager for some containers to do your job, to run your application. You again use this AMRM client protocol and you add the container request. You request for the containers. Once resource managers have identified the containers for you, it will return back with a list of allocated containers. Resource manager now has assume that resource manager have got all requested containers. What resource manager will do is it will initiate the container launch context. Now I have deferred that question from last slide. What is container launch context? This is the information which is required for a container to launch, required by node manager to launch your container. This information has information. This has the information like what all commands you need to run when you launch a container, what class path or what all other environment variables you need to set, what local resources you need to access. Like let's say you want to run a Java jar when you launch a container, so which jar you need to refer, or you need to run some scripts when you launch a container. So where are those scripts? All this information is listed down in this container launch context, and that will be given to the node manager to launch your container. So we'll see how what happens next. So you contact as an application master, you contact node manager using this NM client protocol, and you ask it to start the container. And when you ask to start container, you need to provide this container launch context, all this information. So now node manager will read all this information from container launch context, and it will execute whatever code you have asked for. Like it could be script, Java code, some other language code, some command. It could be anything. It will just launch it. That's why we say there is no restriction like what kind of code you can write. It will just launch it for you, like whatever you ask for. And the next thing, when your containers are actually launched by a node manager client, your application goes in running state, and everything is working now. Now, like your application master need to end this application sometime. That's why it will keep checking the status of all the launched containers. So it will keep asking resource manager by using this get completed container statuses. And when it detects like let's say it has spawned 4 containers, when it detects like all 4 containers are done, it will unregister itself as application master, and this process will be ended. So I think I have just like whatever we have seen as a diagrammatical flow, I have just shown what would be the pseudocode to write if you want to write an app, if you want to launch your application on top of YARN. So here I have not mentioned like what application code you will be submitting. That you need to set in this container launch context, like what command you need to run when you launch the container. Again, that could be, I'm just repeating myself, like that command could be anything. It could be Java code, command scripts, anything. By using this these steps, you can you need just write that this client process and the app master process, and you are good to launch any type of application on top of YARN. I'll again pause for questions.
Yeah, Kamlesh, go ahead.
So Priyanka, when would you suggest to write your own custom application master instead of using the default one that comes out of the architecture itself?
Like one quick thing comes to my mind, if you want to do, if you want to provide some extra capabilities, let's say Apache Slider or some basic projects are already there, which will help you to do all these. I mean, most of these steps are common, like register application master, do container request and all. So if you want to do something more than this, that time, let's say taking very simple example like of Apache Apex, like what we are. So we want to do more than what Hadoop provides. We want to monitor our containers. We want to give some capability to run commands on top of container remotely from application master. So we need to do a lot more than what is provided by Hadoop. That time we will write our application master, and we have already done it in Apache Apex. Actually, Chinmay from data government is going to conduct a session next Tuesday, which will explain how Apex is a yarn application, where we will see like one example of writing like why someone will write his or her own app master.
Okay, thank you.
Yeah. Done. So there was some question about references. So one thing like the pseudocode I have given, the Hortonworks has one Git repository where they have written this very simple application, simple yarn app. It is very good example to understand very basic yarn application. If you go through it, I think it will explain most of the things which I have already covered. Another thing is I have just listed some resources from Hortonworks and Hadoop website itself, which helps to understand yarn architecture really well. And there are some, saw some good presentation on SlideShare as well, so I just mentioned that also. I'll mention one more thing. Okay, I'll mention one more thing. Like as a community, we are very active. So we are very happy to hear your discussions. So if you have any use case discussions or user related question, please subscribe to our mailing list, which is users@apache.incubator.apex.incubator.apache.org. If you have any development related questions, write to us at dave@apex.incubator.apache.org. Join our LinkedIn, Facebook group, follow us on Twitter. Like we would like to keep you updated and hear a lot from you to grow as a community. Now again, I'll pause for questions and I'll.
So there is a question from Mr. Kumar.
Mm-hmm.
Any optimizations in yarn, this is specifically to speed up things?
Okay. So I'll optimizations in the sense I think it depends mainly about your application, what you are writing. If your application is going to need a lot of memory, you can change that, like what container memory, minimum container memory or maximum container memory you need to set, or I don't know, maybe locality, like you can, when you launch the application, let's say you know that two of your containers are going to share a lot of data, so you can request yarn to make them node local or contain, like so they're running on the same node and they don't use a lot of network bandwidth or any other resources to communicate. So when you code, you can do lot of things, but right now there are not many examples which come to my mind. You want to add something?
Yeah, I think it depends on more on the use case side, what exactly you would like to do.
Okay.
So there is one more question from Pankaj. Go ahead.
So Priyanka, can you talk about what testing approach do you guys take while building application and before deploying to live?
Testing approach, you said, right?
Yes, testing approach. Like how do you test at like development level, at QA level, at staging level? If you can put some light on that, would be great.
Yeah.
Yeah, Pankaj. So basically, it's done in steps. The first thing is you would like to have a bunch of unit tests to handle all that. You are sure the basic code that you have written is right for each of the functions. Then in case of, let's say, Apex, which is a yarn application, Apex also provides a local runner type of thing where you can run your application or whatever flow you have written, the DAG we call it, as is within the dev environment, like within Eclipse or something like that, as an test case. So that is like the first case where you will find out most of your smaller bugs or bugs related to the code. The next thing we do generally is we have a Hadoop cluster on our local machine itself, and then we deploy that on a single node Hadoop cluster and see if the things are working in actual Hadoop cluster. Although single node, but that's another step where we see that yes, are the things running or are there any things when it goes to the actual cluster. And the final thing is when we test it on a cluster, which is a test cluster, but it's a considerable big cluster of like 10 nodes with considerable more than a terabyte or 2 terabyte of memory, and actually trying to give a load which is comparable to your production load. And that's where the real challenges come, because in a distributed systems, one operator might be, or one of the container is doing some function or computation that's wrong, but typically it is getting caught sometime later, and that's where you need to have that experience of debugging or understanding the application as a whole, that which part of your say work depends on which part. And but these are the general steps that we follow.
Right. Thanks for explaining that. The other question I have is what Hadoop distribution are you guys using, or is it just a yarn because you are using yarn, so it's only by hot and work? But you guys also look into MapR or Cloudera. What is the decisive factor choosing Hadoop distribution?
Yeah, so we support all the Hadoop distributions, MapR, Cloudera, Hortonworks, and we are certified on that, as well as we run on Google Cloud as well as Azure and EMR. So as such, we are not any specific.
We just need yarn.
So any Hadoop, we do need Hadoop 2.2 onwards because it's a yarn native application. But apart from that, we work on any flavor of or any version of Hadoop.
So does MapR Cloudera also have support for yarn?
Yes, because inside they have Hadoop and Hadoop has 2.20 onwards yarn included. That's the de facto resource manager. 2.1 onwards, sorry, Hadoop 2.2 onwards. Thanks.
Got it, thanks.
Yeah. So there are some more questions, I'll read them. Any optimizations is done. There's a question in which part where are we taking care of security vulnerabilities?
Actually, Hadoop has some basic things like whenever it allocates containers, it will distribute some tokens so that only particular application master can talk can talk to node managers and ask it to launch containers, so that no application master can randomly tell node manager that I've got this permission to launch this container and please launch it. So I mean, application master is again a not trusted process. I mean, it can just do a follow up and launch any number of container and take your cluster down. So such basic security is there, that tokens are there, or even I think that Kerberos authentication is there in Hadoop. So those basic things are already there.
Yeah, I think they are pretty much. The Kerberos is pretty standard security mechanism. Then the next question I have is Mr. Suresh. It says move the processing power where data is. How does resource manager moves for a given application when node manager to run? So in this case, basically, if you have, let's say, MR2, that is where the data locality comes into picture. But in case of streaming applications or where you're processing data in motion, typically it's a step of processes that you do, which can be, we typically call it as a workflow. What happens here is generally the first container or the first functionality is the one which is reading the data or getting the data either from, say, a data locality considered like HDFS or so, or it might be reading it from messaging sources like Kafka. And then onwards, it's generally in memory or the data is being transferred from one functionality to another. So in those cases, data locality directly does not come into picture with respect to HDFS. But what comes into picture here is the connection between two functionalities. So let's say we have A processing something and giving it to B. What we can do is now A and B locality can be arranged or can be configured. So we can say A and B anywhere, or you can say A and B should be on the same node or same rack, or you can say A and B are in the same container also, so that whatever is processed by A directly goes to the B, and here you say avoid serialization of data. And in Linux we also have a thread locality where the data computed by one A is directly passed on to B as a data structure itself.
So I'll just add one more thing. So only when you just consider Hadoop and not Apex. So basic thing is like Hadoop will help you to do data locality with respect to HDFS. But other things I think you will have to manage your own on your own. Let's say if you're reading from Kafka, Hadoop won't know like Kafka about anything about Kafka. So, but it provides you capabilities like it can it allows you to request like and I want to run on this particular node, or not on particular node, but with this like local to say some other process and something like that.
So there is one more question, basic Hadoop question is the same. You have said that without YARN the application has to be written on map reduce. How this issue overcome by YARN?
Okay.
Has to be, so maybe I will rephrase the question. So without YARN in MR1, anything that you want to achieve has to be put into map and reduce only. There were no other programming pattern that were
So
allowed.
processing feature which provided by version 1 was either you do map function or you do write reduce function. But here, like as you are seeing that application launch context, you can actually provide any command to run. That was not possible in version 1. Like you have to actually write the map function and reduce function, which is not the case in version 2.
Yeah. Does Apache Spark comes under the YARN application architecture?
No,
No, I don't think so. But when it runs under Hadoop, in that case, it may be using the YARN resources,
yeah.
but by default, it's not. There was one more question on how it is different from Mesos. Yeah, so Chinmay, can you just take that up?
Yeah, sure. Basically, there are a bunch of differences between YARN and Mesos. I have mainly worked on YARN, but a little bit of Mesos what I know at this extreme. So first of all, a YARN is actually an application scheduler. So basically, what it means is if one has to write an application, it has to write in a specific way as YARN does. But on the other hand, Mesos is a framework scheduler. So, for example, let's say I have to run 1,000 MapReduce jobs and 1,000 Spark jobs in a single cluster. So, in YARN, I will be scheduling individual one of them as the applications to the YARN. But in Mesos, I'll be scheduling those jobs directly to the framework there, and then framework can directly take care of my coordination with Mesos. So I'm scheduling a framework here rather than scheduling an application. Okay, that's one primary difference. The other major difference there is, in YARN, as Priyanka mentioned, the containers are assigned when there's a request. But in Mesos, what happens is when we ask when application master or so similar entities in Mesos asks for certain resource, the Mesos cluster is going to provide a bunch of options for the application master to select, and the controlling entity needs to select one of those. So it's like accept or reject type of framework there. And a bunch of other things related to one major difference being YARN is a majorly developed in Java, and Mesos is pretty much in C++. And another very important point that people think about is YARN as of now can schedule only for memory resources, but Mesos can schedule for memory as well as CPU resources. And I think both are trying their hands on with this specific resource as well.
Pankaj, any last question? I see your hand raised.
Oh, sorry, I forgot to lower my hand. Thank you for your talk and presentation. It was good. Thank you.
Thank you for your questions. Actually, it helped us to add points which we missed. Thanks a lot.
And there is next week there is a session by Chinmay on Apache Apex as an application.
Yeah.
Yeah, application. Yeah.
Sure.
So,
Thank you, guys.
see you next time. Thanks a lot for joining us. We will also upload the recording on our Meetup page. We'll share that. Thanks.
Thank you.
Bye.